So we just finished learning the five decision-making methods: the optimistic, pessimistic, criterion of realism, Laplace, and minimax regret. So now it's a you try it. So I've got a situation here. Sometimes it's rainy, sometimes it's sunny, and there are three options: to sell hot dogs, which does well in the sun; umbrellas, which do well in the rain; and nothing. So our short-term agenda is for you to try those 5 things and get the recommended course of action for each of them. So I will just pause the video, get your answers for the 5 things, and then come back. Okay, so let's just start one at a time. So the optimistic decision maker will believe the hot dogs will make $120, the umbrellas will make $60, and nothing will make $0. Given those choices, they would choose hot dogs. A pessimistic decision maker will believe hot dogs will make -80, umbrellas will make -80, and nothing will make nothing. Given those choices, nothing makes the most sense. Criterion of realism decision maker does a 60% mix between optimistic and pessimistic. Obviously, umbrellas is going to be negative in that scenario. Nothing will be 0, but hot dogs will be positive. So hot dogs will be chosen under criterion of realism 0.6. Laplace, you get an overall payoff of $20 for hot dogs, -$10 for umbrellas, there's 0 for nothing. So hot dogs is favored for Laplace. For minimax regret, we have, in the case of hot dogs, the most we regret is 140, and in the case of umbrellas, the most we regret is 200. In the case of nothing, the most we regret is 120. So we would select nothing. So there's that all spelled out. Notice now, though, that in doing what we've done, there's no way to pick umbrellas. We've done all 5 methods, and umbrellas were never chosen. And this will always be true. There's no value for alpha for the criterion of realism that will produce an umbrellas. So what's going on here? Well, the reason umbrellas is not selected for is it's strictly inferior to hot dogs if we don't assign probabilities to states. So if we're ignoring the likelihood of a particular state over another particular state, then 120 -80 is always going to be better than 60 -80, unless the 60 is a lot more likely than the 120, which is not going to happen using these methods, because any weight assigned to 120 will also get assigned to 60 in any of these methods, as the 120 and the 60 are both the most optimistic scenario. And so we're left without an ability to choose umbrellas, and this is clearly not universally good. And we think about carefully why, or what has to be true for umbrellas to make sense? Well, for umbrellas to make sense, it's got to be true that rain happens more frequently than sun. So even though you lose more, you still lose 80 on the sun, just like you lose 80 on the rain on the hot dogs, and you only make 60 instead of 120 when the weather favors you. If it happens frequently enough, it can overcome the fact that it doesn't make as much when it happens. So if we're living in Seattle, then maybe umbrellas make sense, even if they may not in San Diego. To do that, you need to assign a probability of rain and a probability of sun, which is what we've been avoiding so far. So all of our decision methods have not used probabilities, and now we're going to do it. So we can describe the first methods as decision making under uncertainty. We are uncertain what's going to happen, and this new decision making way of thinking is decision making under risk. So where risk is that we're calculating the likelihood that things occur and then managing that risk by selecting appropriately. So let's see what that'll look like. So if I have a 70% chance of the rain, then if you look at hot dogs, you have on average you'll lose $56 per day due to bad weather, and you'll make 36. So you're down $20. Again, because 120 times 0.3, the likelihood of sunny weather is $36. Whereas umbrellas make $42 from good weather days and lose 0.3 times 80, or $24, making a net of 18. So it's positive. Hot dogs was negative, and then nothing remains 0. And so if we assign 70% chance to rain, state rain, we can justify the selection of umbrellas. So that was a decision made under risk. We assigned a probability to a state and calculated the value of each state for each choice and added them up across choices. Doing that, probability times value for all states for a choice is called calculating the expected value for a state. So it's the sum of the probability of a payoff times the payoff. So here's an example. Suppose I get $9 for drawing an ace of cards off the top of a deck, $1 for drawing a spade. My probability of drawing an ace is going to be 4 out of 52. My probability of drawing a spade is going to be 1 out of 4. So the overall payoff will be 49 out of 52. The expected value of this particular bet is 49 out of 52. And so you just end up with slightly under $1. So this would be, this would be a reasonable table game if you play for $1 and the house always wins. So that 49 out of 52 is the expected payoff of playing this game, and similarly, we can calculate an expected payoff for various choices using probability of getting the particular payoff, the probability of that state, and the payoff in that state. So an important concept when dealing with decision making under risk is the expected value with perfect information. So if we knew what the weather would be, we could have hot dogs in sunny weather and umbrellas in rainy weather. So remember that hot dogs were negative $20, so you would rather do nothing than sell hot dogs every day. And umbrellas were $18. So you would prefer to sell umbrellas than do nothing, but it's not fantastically profitable. Suppose, though, that you knew what the weather was coming. Well, that would mean 70% of the time you would make $60, and 30% of the time you'd make $120. So we'd make $36, an expected value from sunny days, and $42, an expected value from rainy days. So we would add that up and get $78. So $78 would be the expected profit from this business if we knew in advance what the weather would be. So that distinction is important to make, because if we have no way to gather additional information, if we have no ability to predict the state, then the best we can do is $18. If we have perfect predictions, we can make $78. That's quite a shift, and it means that if we have the potential for costly information gathering, we might justify that expense. So imagine that I could pay $40 and get a perfect prediction of the weather, then that would clearly be worth it. Or maybe if I paid $10 to get a somewhat accurate prediction of the weather, that would probably also be worth it. So the value of a choice, assuming you choose if you make the best choice given the state. So if the state shows up, then you make the choice. That's called expected value with perfect information. If you make the choice, then reveal the state, that's just expected monetary value. And if you look at the difference between the expected value with perfect information and the expected monetary value, that difference is the expected value of the information, of perfect information, the value of the information itself.